So students, in this video we will do some examples or two questions basically. And so this is the first question. Find the derivative of sine of 2x with respect to x. That is, find d by dx of, I make the mistake of writing capital S, it is small as sine of x, not x sine of 2x. Okay, now why did I write dx? Because it is with respect to x. Make sure that you understand the terms rightly. Now how to solve this? See, there are two ways of solving it, and one way is the way of composite functions, which you have not studied. So therefore you only know one way. You would learn another way of solving this next year. So anyways, we'll go with the way that you know, and that is by using a trigonometric identity, and that is sine 2x. Now we know, see, I wrote capital S again. Sine of 2x is equal to 2 sine x cos x. We know that much. So we will do that. So doing that much, or let me just take that off. You should write this thing, but I want space to write, that is why I'm taking that off. So doing that much, we can write this as d by dx of 2 sine x cos x. Now there's one thing that I really want you guys to know, and that is when there's a constant inside. See, for example, here, let me take another color. Here there's a constant here, see. So when there's a constant inside, you can always take that thing out of the differential. It doesn't matter, it's the same case with limits. For example, you had if you had limit d, or leave d, limit x tends to 2, if you had 2x plus h, you could put this 2 outside, and you could also write, which this implies, so this is equal to 2 into limit x tends to 2 x plus h. Do you get it? You can always put the whole constant. When there's a constant that you can take common, you can put it outside always. It doesn't matter. So I mean, the value will be the same. Okay. So using all that, whatever we understood till now, so let us take this 2 out, and this is equal to 2 d by dx of sin x into cos x. Okay, now we reach a position of product function sin x cos x. So now we use our left d right plus right d left, that is our product rule. So using the left d right plus right d left rule, we get it. So left function is sin x into differential of cos x, that is d by dx of cos x, plus right function, that is cos x into d by dx of left function, that is sin x. Okay, now what happens? Let us see. Now this is equal to 2 into sine of x, and by the way, in the homeworks you would have understood that differential of cos x is minus sin x. So this will be 2 sin x, and this thing in the hallmarks you have understood that this thing goes to minus sin x. It becomes minus sin x. Differential of cos x is minus sin x. So that will be minus sine of x plus same thing cos of x. Then differential of sin x, this thing also you would have studied when you did the homework. You would have seen that it was cos of x. Differential of sin is cos, and I also showed you the proof by showing the graph and all. So okay, now what do you get? Open the bracket, it will be minus 2 sine square x plus, 2 is common, don't forget that. So minus 2 sine square x and plus 2 cos square x. Pretty nice. Which is equal to 2 I could take common, and then I can write it as cos square x minus sine square x, which is equal to, you could either stop it here, but I would say do on. What is this? Cos square x minus sine square x. What is that? Cos square x minus sine square x. Any remembrance? Do you remember what was that? That is exactly what you studied as cos 2 theta. It's a formula which you studied. So it is 2 of cos, 2 into cos 2 theta. Not 2 theta, 2x here. And this is your final answer. Okay, so I think I think you have understood how to do that. So this is how you will be applying the product rule. Now let us look at a quotient rule example. Find the derivative of cot of x with respect to x. Okay, pretty nice question. Now how do we do this? So what we are asked to do is find d by dx of cot of x. Okay, that is how to do it. For that we need to see what is cot of x. Cot of x is equal to cos of x minus sine of x, right? So applying that, what will we get? D by dx of cos of x minus sine of x. Okay, now we have a quotient function, so we need to apply quotient rule. So therefore when we do that, so remember what our quotient rule was? Right d left minus left d right whole divided by right square, or second function, so that will be sine x into differential of first function, so d by dx of first function minus first function into differential of second function minus, it's always good to keep it in bracket so that you won't make a mistake. So d by dx of second function, that is sin x, okay, close the bracket, whole divided by second function whole square, sin x whole square, or you could write it as sine square x, both are the same thing. Now let us solve that. So let me just change the color. So what will this be? This will be equal to sin x, and d by dx of cos x is differential of cos x is sin x, no, minus sin x. So it is minus sine x minus cos x, then d by dx of d by dx of sine x, that is sine x differential is cos x, so again cos x whole divided by sine square x. Sine x whole square is sine square x, only same thing. Now let us solve that. So this is equal to sine x into minus sine x, that will be minus sine square x minus cos square x whole divided by sine square x, which is equal to minus. I can take common, and what do I get? Sine square x plus cos square x whole divided by sine square x. Now what is that? Again keep on solving. What you will get is this value okay, I should take a nice color, this value is sine square x plus cos square x, that is 1. So writing that, this will be minus 1 whole divided by sine square x, and that is 1 by sine square x is minus cosec square x. So 1 by sine x is cosec x, then into 1 by sine x, that is cosec x. So the whole 1 by sine square x is minus cosec square x. Now, so this is how we solve a quotient function. So I think you are getting an idea of how to solve these type of things. So yeah, do the homeworks, submit it on time, and get ready for the same chapter to come up in the next year. Okay, then bye bye.